All right, we're going to be working on our Unit 5 exercises tonight, where we're going into Chapter 5. The first exercise that we're going to work on is exercise number 3. I'm going to pull that up in the book here from the resources page, if you can bear with me. And then this one is for the Shady Rest Hotel. And I'm just realizing now you guys are not seeing my screen. So now you are seeing my screen. Up until now, you were seeing the Zoom window, and I apologize for that. But we are going to go to Chapter 5, and we're going to find that exercise here. So just please bear with me while I navigate through here, just so we can read the right exercise. All right, so this is the one that we're working on. So our objective here is to write an application for the Shady Rest Hotel. The program determines the price of a room. Ask the user to choose 1 for a queen bed, 2 for a king, or 3 for a king and a pull-out couch. The output echoes the input and displays the price of the room, $125 for queen, $139 for king, and $165 for the suite, with a king bed and a pull-out. If the user enters an invalid code, display an appropriate message and set the price to 0. Save the file as shadyrestroom.java. So we're going to do this part first. So let's begin with this. So back in Eclipse, I'm going to begin by creating a new project, because we are now working on a new exercise. And I'm going to name this one Chapter 5. Now that we have our project node here in the left sidebar, let's go ahead and right-click on the source folder and choose a new Java class. All right, this one, they would like us to name it Shady Restroom. So I'm going to name it exactly that. And I am going to go ahead and click the public static void main to pre-create that little piece. And now we got to start to think about this problem a little bit as we begin to code it. And the first thing that I'm thinking about is the fact that there's a selection that needs to be made. And I mean, they tell us right in the exercise description that we have to select 1 for queen, 2 for king, and 3 for suite. And so to me, it makes sense to add some stuff in the program here that will kind of work with us to allow that to happen. So the first thing I'm going to do right up here at the top is I'm going to create a variable that's going to allow me to capture whatever selection the user makes. So I'm just going to create that as an integer. And the reason I'm doing that is because I paid attention to the instructions, and the instructions said that they want the user to choose number 1, 2, or 3. So, hey, an integer sounds like to me. The other thing that might be very helpful here is to also have another integer, in this case, to hold the price of the room. Now, I'm going with an integer on this, by the way, because I noticed from the exercise description that the prices were all in whole dollar amounts. And so I don't really see a functional reason to put a double in there. I'm not expecting the room to be 125.49, for example. It's going to be a round number. And so I'm just going to use an integer for the price. Now, since we're going to allow people to make a selection, and the selection that they're going to make is going to be fixed, I might do something like this. So I might create an integer, for example, for queen. Now, you guys are noticing probably that I'm doing this all caps, which implies, well, you know what? This should probably be a constant. So let's put the final keyword in front of it to make it a constant. We don't want that to change. So 1 will always represent queen. Well, since I have a couple more things to do here in that same way, I may as well add king as a 2 and suite as a 3. And I'm doing it all on one line. So all of them are integers, all of them are constants, and they're all in the same line with a preset value. Those aren't going to change. Another piece of information that we were given that's in the same category are the prices of those rooms. And you know what? I don't anticipate those changing either, at least not right now. And so I'm going to also set those as finals and integers, predetermining all of them. So if you remember, the price for a queen, so I'm just going to do Q price, that works for me, was 125. The king price was 139. And then the suite price was 165. Now, you might not have thought to make these things even variables, perhaps, or maybe you didn't think about making them constants. And honestly, that's quite all right. But that's where my mind goes when I do this. And looking at the author's solution as well, he kind of thought much along the same lines that I did. Now, in order to get information from the user, of course, we need to get the scanner into play here. So let's call upon the scanner. We're going to do a control space after we type it to add the library for the scanner, and then we're going to create a new instance of the scanner, and I'm going to call mine, I don't know, in for input. If you want to go ahead and, I guess, you know what, I'm going to just call it input. May as well have the whole word. And then we'll do a new scanner and system.in, which is a pretty standard procedure for us. So now we're ready. Now we're ready to capture information from the user if I can type it correctly. And as soon as Eclipse app's doing its own darn thing. All right. So the next thing I'm thinking about here is I need to ask the user to input some information on the screen and then select from it. And to me, that sounds more like, like a menu. So here's what I'm going to do. And I'm going to get slightly verbose with this. And I realize that you guys will probably be scurrying to catch up, but I'm going to do a series of system out print lines here to basically put what I'm thinking of as a menu on the screen, albeit from the command line, but whatever. It's a menu on the screen that will show the choices to the user and then prompt them and ask them to make a selection. And so the first part of it is I'm going to throw in a system out print line with a couple of escape characters thrown in. So if you guys remember what these are, if I do this escape character, what does that one do? Does anybody remember?
A new line.
That creates a new line. So what this is going to do is create two new lines and then put in the word menu and then another blank line after it. What does this one do?
That's a tab.
That's a tab. Right. So let's see how this looks when we're all done. Excuse me. The next thing I'm going to do is I'm going to put my menu options on the screen. So I'm going to do these one at a time, but the pattern's going to be the same for all of them. So the first one, I'm doing a system out print line, and then I'm doing really carefully, I'm putting in parentheses. So I actually want that to appear, and then I'm throwing in the number 1. I could just type the number 1, but I'm doing it with a variable for whatever reason. And so just to kind of make the point here, I could have just done this, right? I could have just said, with the parentheses, I could have said 1, but instead I'm being a little bit more verbose with it. And more importantly, I'm being dynamic with it. And here's what I mean by that. The number 1 is going to appear here, and that's pulling this value from here. But what if I started to add more room types? And what if I started to add, more complicated things? I could preset the constants. All I have to do is call upon it, and then it'll automatically put the number here. So what was the number code for double king? Oh, geez, I don't remember. It would automatically pull it in for me. That's kind of the point. All right. Now, I'm also noticing that this is highlighting red. I'm going to come back to this because I'm going to create a message to put in this spot here in just a moment. The next thing that I'm going to do is I'm going to paste in the code for the king suite and for the king and the suite. I apologize for kind of mixing up the words there. All right, so that's the first part of it. And then finally, I'm going to ask the user to make a selection. So enter selection, 1, 2, or 3, waiting for them to type something. And then, of course, we are going to take whatever selection they made. I'm going to store it in the selection variable that I created. See why that name is useful here. And I'm going to set that equivalent to the input scanner grabbing the next integer, like so. Okay. Now, what's going to follow here, and I'm just going to put in a comment, then we do the selection logic. That's what will follow down here. But I want to address this issue first, because I'm copying and pasting code without talking through what I'm about to do. But I'm dynamically pulling in the number for the queen suite, the king and the suite. And then I want to have a message to go with it. And so the Q string might, for example, be a message that just says queen bed. Or K string might be king bed with a view or a TV set. I don't know, it's mini fridge, whatever. And what I'm going to do is kind of follow the same approach I did with the price and the selection numbers. And I'm going to create another set of constants up here where I will put the messages that will populate each one of these. So you can notice I have a Q string that'll say queen bed, a K string which will say king bed, an S string which is going to say suite with a king bed and a pull-out couch, and then another one that's just for errors, by the way, which is going to be called invalid string. And then it'll put a message on the screen that says invalid operation. Now, if you remember from the instructions, and let's just bop back there really quick, display an appropriate message and set the price to 0 if the user enters an invalid code. So that's why I'm creating that one. So it's just a pre-created message. And whenever I want to use that message, it's already typed up. I just call upon that variable and it'll type it in. All right, so that's kind of the anatomy of the interface. Now, if I want, I could go ahead and run this right now and see what it looks like. Let's actually do that. Let's see what it looks like. It should be okay. There's no red marks anywhere. Let's save this. We'll do a Control S, and let's just see what it looks like so far. I want to see what the interface looks like. So we're running this, and that's what our menu looks like. Now, the one thing that I noticed, and we talked about this tab stop. I don't know why they put it in there. I think what they really meant to do is to move the menu over a little bit. And so I think the author meant to put it here, is my take on it. So I'm going to run this one more time. And notice how it tabbed it in. Now, whether or not that looks better is completely up to you. I'm not really digging it so much. But the one thing that I would do if I wanted to make this look more like a menu, this is just me, mind you, is I might do something like this. With my primitive ASCII art here, something like that. Maybe even a few more dashes. Right. I might also take that line and repeat it again. And this is, personal preference, not a requirement in any way, shape, or form. Something to that effect. All right. Let's go ahead and save this again. Let's run it. And so what I'm doing is I'm just basically previewing what I'm showing my user before I send it out to them. I might add a few more dots here. I don't know. We'll see. I think something like that would probably be adequate. And this is just to ramp up your ASCII art skills here, folks. All right. Run it one more time. What do you think? Hey, we're pretty close. It looks like I need 1, 2, 3 more dashes if I really want to be perfect about it. So I'll do that. And we'll save it. All right, now let's go on to the part that we're here to learn that's brand new, which is how to create if statements and how to use them properly in a program. All right, so the first step is going to be this. Right inside the main method here, I'm going to begin by just saying if. And what I'm checking is the only thing that I can check, which is what the user entered. So they entered 1, 2, or 3, or the wrong number, one of those things. So I'm going to check to see if the selection that was entered is equivalent to queen. And then inside curly brackets here would be the result of whatever happens if that user presses the number 1 for queen. Okay. Now, some students will say, couldn't you just have hard-coded a 1 there? Yes, I totally could have. Absolutely. But this value here represents the number 1 in form of a constant. Plus, when I look at the code, it's a lot easier for me when I'm reading my code to associate it. Okay, they selected queen. All the stuff inside here should go with queen, and we'll be okay. So what we're going to do is we're going to take whatever selection was made, and now we're going to say, okay, well, if they selected a queen, the price is 125. So let's begin by setting the price to 125. Okay. The other thing is, well, you know what? We're trying to keep track of what we're selecting. Maybe we should create another variable to hold the result. And you think of the words I'm using here, the result of the selection that I'm making. So I'm going to come back up to the top and create the variable first. So I'm going to probably put it here. This seems to be a good spot. So I'm going to create a string, and I'm just going to call it result. I'm not going to pre-populate it with anything. Okay. Now down here, I'm going to feed a value into result. And what am I going to feed a value in? I'm going to feed in the string that says queen bed. And so I'm going to say Q string to feed in that. Okay, so see, Steve, you asked a very pertinent question in the chat window. And you know what, sir? You are absolutely correct. So wouldn't it be better, instead of me typing 125 there, wouldn't it be better for me to feed in the value that's already hard-coded from above? Absolutely. I'm just going to say Q price, just the way I did Q string. Now, a lot of people say, why are you doing it like this? Why not just put the numbers in there? Well, because if I use this approach, if the price changes, I want you to think about this, I only have to change it one spot. That's the beauty of it. All right, so now that we have this part set, what if the person does not make the selection of queen? So now we have to check for another scenario. So this is where we add an else clause and with it another if statement. So not only are we doing something else, but we're checking to see if a different condition is true. And in this case, we're going to check to see if the selection is equal to king. Now, interestingly, when I do this, I want you to notice a couple different things because we didn't talk about this. Whenever we have an if statement, whatever goes inside the parentheses is something that's being tested to see if it's true or false. And if true, we perform whatever actions follow that if statement inside a set of curly brackets. If it's not true, then we move on. We might check another condition, or we just might move on to our code. In this case, we are checking for another condition. Now, interestingly, we can follow the same approach we did here with the queen bed. Is if somebody selects king, we'll do the same thing, but now we're just going to change it to the king price and the king result. Now, what if this one doesn't catch? Well, then we'll put in another else if and check the other scenario, which is if the selection is a suite. And I got to spell that right first. Then we will perform one additional action. And what will we do with that? Same basic approach, you guys. So we can copy this little tidbit here again. We're just going to change that first letter because we were smart about how we set up our variables, right? So all we have to do is change one letter here to fix it after a copy paste. All right, now I want to talk about what happens next? What happens if they make a selection and it's not queen, and it's not king, and it's not suite? So it's not 1, 2, or 3. What if they type J or 0 or something, or 42, right? That's not a valid choice. Now we need a scenario to catch that problem. And so we're going to add an else statement at the end of this. And now we're going to drop in a couple pieces of code. So the first thing is that result, instead of being, the string that goes with the room type, is now going to pull in that other thing that was called invalid. Oh gosh, I don't even remember how I typed it. Yeah, invalid string. All right, so we're just going to paste that down here. And of course, that's going to read an invalid option. And then finally, we're going to add the price, which in this case was determined if they make the wrong choice, the price becomes 0, which makes sense. And so if they don't select the right one or type in an errant character, it'll say invalid option, price 0. Finally, the way that we're going to test to see if this worked is we're just going to do an output message. So we're just going to do a system.out.println. And inside here, I'm going to type the following message. I'm going to copy paste it in for speed. And so this will be my output. System out println, you selected whatever you selected, and here's the price. You want to format it, do the formatting commands, go for it. Right now, I just like to see the numbers up on the screen. So let's see if we can get this to work. I think all our code's okay. So just kind of a really quick review of the code. Then we have our menu and our if statement. And then finally our output. All right, let's give this a run and see if it works. I'm going to expand the console so we can see it better. And let's go ahead and hit that run button, save our file. So here's our menu. And I'm going to click into the window to make the console active, and I'm going to type in my selection. Okay, well, it seems to have worked. Let's run it again. Let's test each option. This time I'm going to test king. Run it again. This time we're going to select the suite. One more time, and let's put in something that's nonsense, like 55. That's working too. Let's try to break it. Let's put in some letters. Okay, and that's where it breaks down. And why does it break down here? Why does it do this by typing in letters?
Is it because with the selection variable we declared at the top, we set it as an int and not a string?
Correct. That's absolutely right on target, Laren. We set the variable that's receiving the value. So in other words, the selection is grabbing an integer, right? And it is of an integer type. Okay, so if people type in letters, well, then it's gonna blow up the program. Now, here's the interesting thing. We will learn how to work around this problem. We will also learn how to get to the point where we run a program like this, where you can keep making choices and not have to restart it each time. But that comes with looping. But in terms of the first part of this exercise, this is the completed version. So if you guys are trying to screen capture code here to get yours to work, here's the top part of my code up through line 28, 29. And here is the bottom part of the code. And just remember, the video will be out there probably by tomorrow, so you can always get it from there too. But that is the first part here. This is exercise 3A, the shady restroom. Now let's read the next part. Let's see what they are asking us to do. It says, add a prompt to the shady restroom application to ask the user to specify a lake view or a park view, but ask only if the bed size entry is valid. Okay, so that's kind of a weird little phrase. add $15 to the price of any room with a lake view. If the lake view value is invalid, display an appropriate message and assume the price for a room with a lake view, and assume that that is the price for. Okay, I see. So I'm not really reading it too well. And we're going to save this one as Shady Restroom 2. All right, so let's get started on this one. And we are going to start with the same code. So I think that probably a real smart play here for us is that inside of Eclipse here, let's just go ahead and make a new file, new class file. Let's call it Shady Rest Room 2. I'm not going to worry about the public static void main, and I'll show you why in just a second. I'm going to let it create it because I'm going to come back to this one and I'm going to, copy the whole darn main method verbatim, and then we're going to tweak it. Yes, I'm aware that I'm not grabbing the scanner, but I'll fix that in a second. So we're going to paste that in to the program. The scanner should, it grabbed the scanner for me too. Thank you, Eclipse, right? So it saw me pasting it in, it automatically added the library for me. How convenient, right? Right. Make sure you save that before you go any further. And now let's think about the alterations that they're talking about. Do we need to change any of the stuff up here? I don't think we need to change any of this stuff. Do we need to change our scanner or our menu? No, not at this point. But at some point, right, at some point, we need to ask them about this whole Lakeview thing. And so here's where we're going to start with that. The pattern of selecting king, queen, or suite is still going to be the same. So we're going to start the program the same. We're going to have the same selection of if statements here. However, we're not going to go to an output directly. So this part is going to change. And what I'm going to do for right now is I'm going to just put 2 slashes in front of it to turn it into a comment, and I will come back. Okay. Now I got to think about this. If the user came into this program and correctly selected either queen, king, or suite, and only if the selection was correct, I want you to think about that, then we can move on and ask them if there's a lake view or a park view, right? Because if they made the wrong selection, there's no point in asking them. You see the logic there? So one way we could test before we ask them about lake or park view is to check and see if the price was set to 0. Now, I want you to think about this. If they didn't make the right selection, the price becomes 0. So now that becomes a good thing to test to see if we want to ask them for the next series. So I'm going to now create an output. So assuming that they made the correct selection, now they get the option for lake or park view. And I'm going to do this once again systematically. So I'm going to do a system out print line here inside the if statement. Please choose a view. And then I might give them a lake view and a park view. And now I'm thinking back to this approach that I used here, where I had a predetermined number for lake or park, and then a predetermined message string. And I want to do the same technique because I think it's a clever technique and I think it's a good technique. And so let's start by adding in a couple of things way up here at the top. All right, so we're going to kind of separate some of this stuff out here. So we're going to add, I'm sorry, not what I meant to change here. I wanted to go farther up. I wanted to add a couple of things up here. So I'm making a little space to add them. The first thing I'm going to add is, why don't we put in the numbers 1 and 2 as constants once again for lake and park. All right. The other thing is I want to put in a message. So I want to have those predetermined messages. So I'll have one L string for the lake, one P string for the park, and then also an error string. So if they make the wrong view selection, we can say an invalid view, so using lake. All right. And so that was kind of a little caveat they were trying to throw into the program there. I'm not sure I like that caveat a lot, but hey, there it is. Now, the other thing is if we do throw in one of these options, then we're going to add $15 to the price because it's a premium offering. And so what I'm going to do is I'm going to create a constant called Lake Premium, or L Premium in my case, which will add that $15. So whenever I want to add that $15, I just throw in L Premium, and that will kind of throw that into the mix. So I pre-created my error messages, my numbers, and my dollar amount change are all pre-configured. Now I can come back down here, and I know that some of you are probably still copying this, so I'll give you just a second to grab that. Now I'm going to go back down here to my system out print lines, and now I'm going to give them this option. So first I'm going to do Lake, and kind of mimicking what I did above, this is going to populate the number 1, and then the message for Lake View. And then I'm going to do the same thing for a Park View, like this. And then once again, I'm going to prompt my user to enter a selection. And you know what? I'm going to copy this line. It's really close. I don't have 3 options. I only have 2. But you know what? I can do this and kind of get it all done. So enter selection 1 or 2. If you want to pretty things up like we did up here, go for it. I'm not going to worry about that right now. Now, once we have prompted them, then we need to gather the information again. So now I'm just going to come and grab the selection line. We're still doing the same thing. We're still grabbing an integer from the prompt. So let's allow that to happen. Now, even though we're inside the if statement, now we do more logic. So now we're doing another selection process. So here we will begin with a new if statement. Once again, we will check the selection. So I'm going to type if selection equals Lake or 1. Then what are we going to do? Well, here's what we're going to do. First, we're going to take the price, whatever the price is currently, and we're going to add to it the Lake Premium. So add that $15 to the price. Now, you guys notice that I did a plus equals on this. That's the same as saying price equals L Premium plus price. To me, it's easier to type this. Plus equals is the same. You're just taking this value, adding it to price, and storing it in price. That's what it says. The other thing is that we have kind of like this need to display the fact, are they getting the view or not? So we need to put that message on the screen. So now I'm thinking to myself, if I'm going to put a message on the screen, it's kind of like result, but results already being used for the price, sort of. So can we create another string up here at the top? And let's call this one view. And actually, I'm going to preset this one to say no, because if they don't make a selection or whatever, we might want to say no. Did you select a view? No, you did not select a view. You know? So I'm just presetting that one is my thinking. So down here, I'm then going to take the that view variable and set it to the Lake string. And so if they choose Lake as an option, what's your view? The Lake view. So that's what the screen will say on output. But I got a plan for that in advance. All right, if they don't make the selection of Lake, then we go into that else if mode one more time. And now we're making a different selection, and we're looking for Park, or the number 2. Curly brackets once again. And what's going to change here, by the way, is just the message. Now, if they're selecting the Park view, there's no upcharge, see, right? So if they select Park, they just got the Park message, no change in price. No need to add this part of it. If they don't make a selection, right, then we go into the else mode. And then what did the instructions say? Well, the instruction said if they don't make a choice, give them a Lakeview. They want to upcharge them is basically the point. So I can just take this whole thing, the price part, we can add that here. And then since they didn't make a selection, the message then would be the error string that we had above. And what did we name that here? We called it view error string. So I'm just going to copy that whole thing and drop it here. So it's going to pull in that string message. Now we need to do our output, and we're going to revise the original just a little bit from what we had it. So you can see this is the original up here. And the new revised version of this, you got to be really careful where you place it, because if you look here with these curly brackets, and this is where it gets kind of a little bit weird, is how do you know which curly bracket matches up? And I don't know if you guys can see this on my screen, but when I click next to this curly bracket, you notice this one gets a little box around it. And when I click next to this one, that one gets a little box around it. And if I click by this one, that one down here gets a little box around it. And what I'm trying to do is get my output statement outside of this if statement. And I want it to sit above the second closing curly bracket right here. So this is what I would like it to say. And I'll try to get it all in one line here. And I don't know if that'll work for you or not, but this is what mine is. So you selected Queen with a Lakeview for whatever the price turns out to be. All right, I'm going to go ahead and run this now. So this should solve this one. So let's do a Control S to save. And I'm going to do a run. All right, so here we are with the menu. I'm going to go ahead and select, I'm a big fan of king beds. Let's do king bed. Now I can choose my view. Please choose a view, a lake or a park. And I'm going to go with, hey, you know what? I want to be upcharged. I'm going with lake. And you selected a king bed with a lake view for $154. Now, really what I would like you to do when you run these is I want you to make sure you try all the different selections and see what happens. I'm pretty confident that the first set of selections works just fine. And so I'll make sure I always type in 1, 2, or 3 to not get an error message. But let's run it again. And this time, let's select 3 this time. And this time I'm going to select park. And it says you selected a suite with a king bed and a pull-out couch with a park view, which is correct, for $165. Let's try it one more time. And this time we'll do the queen bed. And this time we won't make a selection. Or maybe if we type in a 3, okay, here. All right, you selected a queen bed with an invalid view, so using lake view for $140. See how they upcharged us. Now there's another scenario that we didn't test, and here's the scenario. What happens if I type the wrong number in here? So if I type a 4, that's what happens there. So it all falls through. All right, so that's the working program, folks. Let me just quickly review the code on this one. This is exercise 3B from chapter 5. This is the top part of the code through line 28. And line 29 through 56. And then the rest of it. All right, we're moving on. We're going to exercise 7 now, and let's read through the description here. It says, create a class that holds data about a job applicant. Include a name, a phone number, and 4 Boolean fields that represent whether the applicant is skilled in each of the following areas: word processing, spreadsheets, databases, and graphics. Include a constructor that accepts values for each of these fields. Also include a get method for each field. Create an application that instantiates several job applicant objects and pass each in turn to a Boolean method that determines whether each applicant is qualified for an interview. Then, in the main method, display an appropriate method for each job applicant, and in a qualified Job Applicant has at least 3 of the 4 skills. Save the files as Job Applicant and test Job Applicants.java. So where we're going to begin here is we're going to begin by constructing the class that we're going to instantiate, which is going to be called Job Applicant. So let's get started on that. Let's go back over to Eclipse here. I'm going to create a new class file in the Chapter 5 folder. I'm going to call this one Job Applicant. And remember, this is the one that's going to be our blueprint file, or the class file that we are going to be replicating as objects. We do not need a public static void main. And let's go ahead and click Finish. So we have the basis of our class file already present here. Next step that we want is to create all the private variables that they talked about. So I remember from what they described here that there should be a variable for the person's name. Let's just do that all lowercase, so that'll be a string. We also need a variable for the phone number, and that will also be a string. Now we're going to talk about the other skills that they were mentioning, and they wanted us to do these as Booleans, which is kind of strange. But you guys remember what a Boolean is? Can somebody tell me what Boolean means?
It's basically just like a value that's either true or it's false, or it's like it's a 1 or it's a 0. It's either like 0.1 or not. It's
right.
But yeah, it's just like the true false.
Yeah, true false is kind of like the easy answer, Laren. Very good. So the first variable I'm going to create is has word skill, is what I'm going to call it. And so if they have skills with word, this value will be true, right? So that's all they either have it or they don't. And very much in the same way, I'm going to create variables for the other 3 things, which are do they have a spreadsheet skill, and do they have graphic skills? All of them are Booleans. And notice how I word it, right? Because the wording is important too. And if you name your variables right, they can make a lot of sense. So if I name it has graphic skill, true or false, I mean, it kind of answers itself as to what it means, if you see where I'm going with that. So choosing the names helps quite a bit. Now, they did mention that they want us to create a constructor that allows us to feed all of those values in. So I'm going to begin by doing that. So here's what that would look like. So once again, we're going to repeat the class name, and then in parentheses, we're going to allow them to feed in all of these values. So I have a string for name, a string for phone, and then word, spreadsheet, database, and graphics. That's what those letters for. If you're not comfortable with naming these variables the same as what's in the class up here, you can change those. So if you wanted to, let's say, just abbreviate these and just say something like N or P, you can totally do that. So let's go ahead and do it. All right. Then we need a set of curly brackets here for this constructor. And what we're going to put inside here is something like this. And we're going to use the self-referring object name. So which name are we talking about? This name, the one that we're dealing with. And we're going to feed to it the letter N. And which phone number? Well, this phone number attached to this individual. And then we'll go through each one of these variables up top here. So you can just kind of do this if you want to kind of shortcut it here. And do they have word skills? And you can grab each one of these one at a time and paste them in. In fact, I might paste them all in first. Oops. And then feed the variables into it. Which variables are we feeding? The ones that are listed up above. So it'll be W1's already done, spreadsheet, database, and I'm forgetting my semicolons. I am noticing. just in case you think I'm not. But I can always come back and fix those. And let's get those semicolons in. All right. So this is going to allow us to apply these skills to these individuals. All right. What do you guys think? Should I put a this statement in front of all these?
You actually don't have to put them in front of any of them.
Yeah, you don't. And that's a really good point. You actually don't need to include it at all. There are some circumstances, though, where you do want to include it. I just like to talk about it. I could include it in front of all of them. In this case, looking at the author's example, he only included it in front of 2 of them. So I'm wondering if he has a purpose for it. I'm not seeing the purpose right now, but maybe he does. All right. The next thing that we need to do, and I read the instructions really carefully, is that I don't need to set any of these values externally, but I do need to be able to get all of these values externally. And so what I'd like to do now is create setters and getters, but we're going to be kind of selective about how we do that. So I'm going to come down here and I'm going to right click. Remember, if we go to source and then generate getters and setters, and let's see if we can kind of manipulate the tool here a little bit into giving us what we want. So the first thing I'm going to do is I'm going to expand all of these. And I want to show you something that's kind of interesting about this, because these are all named a little bit differently. And I want, when they're doing setters and getters here, normally we're used to seeing these things say set and get. But notice that because these are Booleans, these are being switched to say is. And so I'm going to let it do what it does, and then I'm going to change it, by the way. I'm just going to let you know that. So I'm going to just select the getters. We weren't told to get the setters in the mix here. So I'm just selecting the getters. And in the case of the Booleans, those are called is. And the thinking behind that, by the way, is if something is true or false, you ask the question, is it true or false? That's why you say is has word skill. I guess that doesn't really read well English-wise, but that it's true or false. I'm going to go ahead and...
I think there's one more up on top there.
Oh, did I miss it? Oh, thank you, Steve. Thank you. I would have been creating it manually. I appreciate it. All right, so I'm going to go ahead now and just click OK here and let it create. But I am going to come in here, and the only reason I'm predominantly doing this is normally I would leave these alone, is because the author did it a different way. He changed all of these to gets. So I'm going to change them all to gets also, just so that when I'm using his other example, it remains consistent. So I'm changing these all to get. But the essential result is the same. We're really just using these methods to return whatever values are stored in these variables, these variables up here. And so there's name, phone, get has word skill, get has spreadsheet skill, get has database skill, and get has graphics skill. And they're all gets all the way through. All right. This is Job Applicant. I'm not seeing any red or yellow highlights here, so we're okay. I'm just going to do a Control S to save. And now we're going to go to the next part, which is to test the Job Applicant. So we're going to move on and now create a new class file. So let's come over here to the source menu again, or source folder, right click, create a new class file. And this one we're going to be calling test job applicant. We do want a public static void main here, and we are going to go ahead and do this. All right. Next step is to figure out how we're going to instantiate all these different versions. So they said, I think, instantiate several instances, and to me that means at least 3, maybe 4. So I'm going to go with 4. And for each one of the job applicants, I'm going to do a kind of a process like this. And so I'm going to start by getting rid of that. So first I'm going to call in the job applicant class that we just created. And I'm going to call, let's say the first job applicant, how about application 1. And so we're going to create a new job applicant. and then we're going to feed in some information. And so I'm going to close out the statement first, and I'll come back and start feeding in. So first thing we're going to feed in, if I remember the order, and if you don't, you can just look here, because this is the order you have to do it in: name, phone, Word, spreadsheet, database, graphic. So we're going to start with the name. Let's say, I don't know, Johnson. Let's do a phone number here. This person apparently lives in Chicago or something. Do they have word skills? I'm speculating here. True. Do they have spreadsheet skills? False. Do they have database skills? True. And do they have graphic skills? False. Okay. So that's an example of one job applicant we're creating. Now, I do have a few more that are pre-created here. So I'm going to just paste these in like so. And you can see the format is a little different here. And you can follow that format if you wish, if you think that looks a little bit cleaner. And so I have 4 unique job applicants, each with a unique identity. And basically I've created 4 objects based upon the job applicant class, each with their own values. If you want to take a moment really quick to copy those, please do. Now, next thing that we need to do, if I remember, and I do have the book here in my lap, so rather than switching screens, all right, so we're going to, after we create the job applicant objects, pass each in turn to a Boolean method that determines whether each applicant is qualified for an interview. Then, in the main method, display the appropriate method for each applicant. And the qualified applicant, by the way, is one that has at least 3 of the 4 skills. All right, so here's how we have to kind of put that together. First, we have to construct this Boolean method that they're talking about, right? So what if we call that method, if it's Boolean, and I'm going to kind of now use like the standard convention here, is I'm going to create a new method, and I'm going to say public static Boolean, right? Because we're going to return to true or false is what's going to happen. And I'm going to call it is qualified. Seems like a good name to me. And then what are we going to pass in there? We're going to pass in a job applicant object. And I'll just give it a generic name of applicant or app. Right? Curly brackets to open and close. And in this method, when we start to determine if somebody is qualified, we're going to be looking at a couple of different things. We're going to be counting, first of all, how many of those things ring is true. So that's kind of our grand goal. So why don't we create a variable here called count to do the counting, and let's preset it to 0. So every time we call this method, it'll reset it to 0. We also want to probably have an internal variable here that's a Boolean that will kind of end up with the result. So we're going to call that is qual. Okay, that's close. And we haven't predetermined what that is. We're going to determine that as we go. The other thing that we want to check against is the minimum skill level we need, or the number minimum that we're looking for is 3. Maybe not a bad idea to set a constant, an integer constant, and I'm going to call it the minimum skill count or minimum skills count, and I'm going to set that to 3. So I'll always compare that. So if we in the future decide to come back and change it and it's 4 out of 6 or whatever, we just change the number. All right. Now we start to test each one of these skills and see if we should add to our counter. So this is going to be pretty easy. We're just going to do a series of if statement here, and I'm going to say if the applicant, and I don't know this, right? Because we're going to have to look in the object. We're going to have to go to the object and say, has word skill. Let's start with word skill. If the applicant has the word skill, and this will return a true or false here, remember, then on the next line, I can just take my counter and add 1 to it. So I'm going to do a plus equals 1. Okay. Now, I want you guys to notice a couple things. I'm going to move on and type some other statements here. But because I'm only putting one statement inside my if statement, I don't need to use curly brackets. And this is one of the rules of Java that can confuse people like crazy. And so I have this advice that I always give my students. Java allows you to do this, and I could go to a next statement here and do like system out print line. It's not part of the if statement. But I always recommend to students that even though it's not required, even if you only have one statement inside of an if, put it inside of curly brackets because it keeps you from making mistakes. Because if you later on think, oh, I want to add another statement, and you forget the curly brackets, what happens? Your code breaks. So I always recommend to my students, every time you do an if statement, even if there's only one statement inside, don't omit the curly brackets. Always include them. You're always better off doing that. Next, let's test spreadsheet skills. Once again, curlies. And this time, we'll do the count plus one again. So we're just checking true or false. Do they have this skill? And then you can extrapolate this pretty easy, right? So the next two are kind of givens. We'll check database. Once again, count plus equals 1. And then one more time here. And this time we're checking graphics. Once again, curlies. Let's paste in our count. So we covered all those scenarios. Now we're going to run another if statement, one more if statement, where we are going to check to see if the count that we've counted up to is greater than or equal to the minimum skills required, which is 3. We could hard code that, but this gives us the ability to be dynamic. And if that is true, then we will change this variable, this Boolean is qual. We will set that to true. So if they have at least the minimum number of skills required, then they are qualified to apply. Otherwise, if they're not, we're going to put an else here, right? And I usually like to do my else's down here, by the way, and then curlies again. Then we're going to set that same value to false, like so, except we will spell it correctly. All right. Once we've done all that logic checking, the next thing that we're going to do is we are then going to return the true false value of is qual, which is going to be true or false, and send it back. Okay, so this is the method that's going to check to see if people are qualified. All right. The next thing that we're going to do is we're going to think about in the main program body, up here in the main method, we are going to need to do a little bit of checking here. So we have to kind of go through this like series of things we need to do. Well, first of all, I'm thinking to myself, whatever job applicants we're going to be dealing with, we're going to be needing to put a message on the screen to show the results of what we're doing. And instead of having, since I've got 4 job applicants, I don't want to repeat my like system out print line stuff, whatever I do. I don't want to repeat it 4 times. It makes a lot of sense to create a method to do that for us. So let's come way down here to the bottom, and right above the closing curly bracket, let's make a little bit of room here and create another method. This is going to be a public static void method. So it's not returning anything. It's just displaying stuff on the screen. And let's just call it display since it's displaying stuff on the screen. And what are we going to send to it? We're going to send to it our job applicant, whichever one we're dealing with. And then we'll also send to it a predetermined message of success or failure that will automatically populate into the method and then display on the screen. I have a pre-prepared statement that I have here, and this is what I'm going to do as an output message. So I'm going to say system out print line. I'm going to get the person's name, the message, whether they're qualified or not, and their phone number. And really kind of the thinking is here, this will only display the people that are qualified that we actually want to call. That's the whole thinking, right? I don't want to have to redo that line 4 times over up above. So I just did it here once, and this will take care of all the work for me. All right. All right, so now let's talk about how we're going to do some of the mechanics here. The first thing I want to take care of is I'm planning to send a success or failure message forward. So I better predetermine those messages up here as variables so I can just feed them down to the display method. So the first one I'm going to put in is this one. The first one is, I'm going to call it qualified message, meaning that the person is qualified for an interview. And then I'm going to have one also for not qualified, which will look like this. And that message will say is not qualified for an interview at this time. I'm trying to be polite. All right. Now we go into the mechanical part of this, the part that's going to get the stuff on the screen. And then for each one of the applicants, I'm going to do an if statement. And I want to show you how I'm going to do this, and we're going to repeat it. So it's going to be once, and then it'll repeat. So for the first applicant, we're going to check, is the applicant qualified by sending them to this method, which will tell us true or false if they are. So what will I feed in? Well, they want a job applicant. So let's first type the name of the method is qualified. And then that's going to require a pair of parentheses there. And then we're going to send to it first our first job applicant, which is app 1. Okay. So I want you to think about this because this is a little bit weird. Because normally we'll put an equation or something in here that'll say like, if count is greater than 0, then do this, right? But in this case, we're sending this off to a method to determine if the person's qualified. It will return true or false. So if it's true, if it comes back true, the person is qualified. So the message that follows will be pretty simple. It will just simply say display. We'll go to the display method, will do the work. The applicant information, applicant 1, and then the qualified message will be the one sent. So we're going to send this message down below, spelled correctly once again, and end the statement. And if they're not qualified, then we're going to display again. We're going to send in the same applicant, obviously, and we're going to say, we're going to send the not qualified message to the display. Okay, so we need to do this for each one of the applicants, right? So this is just applicant 1. So now I'm going to repeat this process. And for the second applicant, I'll do the same thing. And all I'm going to do here, folks, is I'm just changing the numbers. I'm not really like authoring any new code. If my logic is sound, this will work, right? So let's paste it again, change it to 3s. Change it again. This time it'll be 4. And this gives us the capability to check each job applicant. Okay. And if we look at this list up here, they have to have at least 3 trues. So applicant 1 is not qualified. Applicant 2 is not qualified. Applicant 3 is, and applicant 4 is qualified. So we know the answers in advance. Now it's time to test it. So let's do a Control-S to save. And let's see if this works. So let's get that console window into play here. Let's hit that run button. And here we go. All right. Johnson is not qualified for an interview at this time, and it puts up the phone number. Kerman is not qualified for an interview at this time, puts up the phone number. Lawrence is qualified for an interview. There's the number. Mitchell is qualified. There's the number. So this is proof that it does work. Let's kind of go back to the code. So hopefully yours work too. And I just want to kind of quickly review the class file. So this is the class file with the first 2 gets. The class file with the remainder. Then to our test program where we create 4 applicants, our messages, And in the main method, do an if-else to test each one. We have a Boolean method that returns true or false if the applicant is qualified. And then finally, we have the display method. All right, and I realize we went really fast on that once again, but I'm going to pause the video here for just a second and see if we have any questions. And so exercise number 5, which is the game zone exercise number 5. This is a separate exercise actually. Reads like this. It says, in the game rock, paper, scissors, 2 players simultaneously choose one of 3 options, rock, paper, or scissors. If both players choose the same option, then the result is a tie. However, if they choose differently, the winner is determined as follows. Rock beats scissors because rock can break a pair of scissors. Scissors beat paper because scissors can cut paper. And paper beats rock because a piece of paper can cover a rock. Create a game in which a computer randomly chooses rock, paper, or scissors. Let the user enter a number, 1, 2, or 3, each representing one of the 3 choices. Then determine the winner. Save the application as rock, paper, scissors, etc., etc. Now they have a little bit of a history here. So like one thing that we're kind of missing out on is the fact that in a previous chapter, they were kind of doing some of the prep work for this. Now, we've done some of the prep work for this in other ways. So we've already learned how to do a random number generator, right? Where we just generate a few values. So that's going to be necessary here. And if you're not picking up on it, one of the keys to doing this is the fact that you will assign the value of 1, 2, or 3 to rock, paper, or scissors, and maybe in that order. It makes sense, right? Rock could be 1, paper could be 2, and scissors could be 3. So we would write a program that would allow us to randomly select that on behalf of the computer. Then you'll just pose to the user the option, which one do you want to pick? And then depending on their choice, compare to see, did the computer pick the same number as the user? And if so, it's a tie. You got to do it again. If they did not, then you need to determine the winner, and you need to determine it accurately. So here's what I'm going to do. I'm going to pause the video for just a second, and I'm going to bring up some pseudocode logic that will help you solve this. Now, I do want to point out that I probably have a deeper and better explanation in the unit folder with this other video that's a little bit longer. You see, I spent 40 minutes on just talking about the pseudocode for it. And so if you're going to tackle this exercise, what I would have you do is watch this video, write out your pseudocode, and then convert that into code. You don't need to create any fancy class files or anything here. This is just kind of a straight up random number generator. User selects a number and then figure out who wins and put a message on the screen. Typically, this is solved through a series of if-else statements. And so you can kind of play with that all you want. But I think this video will be a better, deeper explanation. But however, I'm going to pause for a second and pull up some pseudocode. Bear with me here just a moment. And so what I have on the screen here is actually a flowchart solution to the rock, paper, scissors game. And it's a little bit more advanced than the level that you guys are at right now, because it also features a loop where you can replay the game. We haven't learned that skill quite yet, but the if logic is pertinent. So I want to show you this, and I think that this would be really helpful for you in trying to solve this problem. So this, the piece of software that created this, by the way, I'm trying to remember what the name of it was, but it's a pseudocoding flowcharting tool that allows you to kind of like problem solve before you write the code, and in some cases actually test it. But let's like walk through this flowchart here, and you'll see what I'm talking about. So it begins by putting a message on the screen saying, "Hey, let's play a game," and you will be prompted. So you will be allowed to pick whether you choose 1, 2, or 3. And you can see we have a statement here where we're checking to see if my pick does. In this case, this means does not equal 1, does not equal 2, and does not equal 3. In other words, if they didn't put in the right number, you're going to have a message that says, sorry, this is not a valid entry. Please try again. Now, I want you to know this is a loop structure We haven't learned that yet, but that's next chapter, by the way. So that's something that you wouldn't do. But what you would actually check, though, is whatever your pick is, the first thing that you're going to do is you're going to see, did you pick rock, paper, or scissors? And then relative to it being true or false, if I pick rock, then I'm setting a value for I pick to rock. All right. If I did not, then I must have picked something else. So I must have picked maybe paper, right? And if it's true, we set it to paper. If it's false, I don't need to check again. And I want you to see the logic of this. So this is an if statement with a if side and an else side. So the else side comes here. Then we do else if it's paper, we now are set to paper. Otherwise, we don't need to check again because the only other option that's left, folks, is scissors. Right? From there, we do another output and we say, hey, you chose whatever, and here's what it is. Now the computer randomly picks. Now, hypothetically, this would happen all at the same time, but this is coding, so we do it here. We let the computer randomly pick one of the three values, and then we take the computer's choices and qualify them. So 1 equals rock, 2 equals paper, 3 equals scissors. Same logic tree here. Same logic tree. Now we're going to compare the two. So now we're going to say, message on the screen, the computer chooses, and we display that on the message, and then we check to see, is the computer's choice the same as ours? Because if it is, if that's true, are the two things that we're picking, then it's a tie. And then in this case, you would try again. You would quit out of the game or loop back to the beginning and start over again. All right. And then that's what these things do. So if they are the same, you loop out. If they are not the same, then we go through the process, and it's really this section of the diagram here that kind of shows the grand logic of how to solve this. And it's really this bottom part that's probably most important. So now that we each have our choice, and the computer's choice is not the same, by the way, as the user's choice, now we start to do a comparison. If I picked 1, we know the computer didn't because we wouldn't even be checking it otherwise. Now we check, does the computer pick 2? It's either true. So if they pick 2, then we know the scenario is the computer picked paper, paper covers rock, the computer wins. If it's not true that it picked paper, it must have picked scissors, right? I'm trying to think of like rock, paper, scissors. Then this false side actually equates to scissors, and it says rock crushes scissors, you win, the user wins. So let's say that we did not pick the number 1, we picked something else. So then we would be on the false side of this, and we come over here, and now we check to see, did we pick the number 2? It's either true or false. If it's true, then we check to see, did the computer pick the number 1? If it did, then we have the winning scenario. If it did not, the winning scenario. So there's this whole cycle here. I hope you guys are seeing the process of this. And what this graphic really shows you are all the logical steps of it. And so you have to kind of reason this out in your head as you begin to code this, and then write these steps down in order to write the code right. All right. So this is the basic logic of rock, paper, scissors. If you watch that other video that I already have posted, that one goes a lot deeper into the solution for solving this and how you might pseudocode it. And pseudocoding now becomes important again. And so we kind of talked about that real briefly at the beginning, because we are writing problems and programs that were really darn simple to solve. Now we're dealing with rock, paper, scissors. Easy for a 5-year-old. Remember that little thing? They could explain it to a 5-year-old in 2 minutes. Now write the code for it, right? But you have to explain with logic. Now, if a scenario is true, what is your next step? And proceed that way. Now, I get that for some of you, this might feel like a super overwhelming exercise. I assure you it's not really that bad. And actually, I think it's a whole lot of fun and teaches you a lot about program logic in the process. We will look at a solution for this next week real briefly. I do not have a video recorded for the solution. I don't plan on recording one, by the way. I like it unsolved out there. I want people to struggle through it. And if you find that to be too much and you're not comfortable with that, I do give you the option here that you could instead complete exercises 1, 2, and 4 from your book and earn the same number of points. This is worth 4 points. And if you don't like to do this one, do this one. And then you can treat one or the other as an extra credit. But I have a safety net here for you. So if you don't like this approach, you can do these extra credits. Now, with these, I will not, again, record solutions for them. Exercises 2 and 4 are even numbered exercises. And if you guys know this, the author does provide solutions to even numbered exercises. So you can actually look those up as a safety net. The other thing that you could do is if you want to really code through this, this might be an excellent exercise, the game zone one, to work collaboratively with some of your peers and figure out the logic and try to code it and see if you can do it. I will be really curious next week when we come back together to see who's tried it and to look at your solutions. And then I will, if I can find them, assuming, show you solutions from some of our previous classes, some of which are pretty clever. We are not using loops here, but one logical extension of this and kind of a precursor to learning looping, which is coming up, is the fact that when you play a game like this, often you want to go again, especially in the tie scenario. If you tie, you want to reinitiate the process and do it again. It's like rock, paper, scissors. You both got rock. Well, let's go again. Okay, rock, paper, scissors. Now you got 2 different things and you can determine a winner. But we haven't learned that construct yet. But it is not too much of a stretch from what we're already learning. I wish you good luck on accomplishing this one. It is a lot of fun. I think of it as fun, and you might see it more as punishment. I assure you that's not my objective here. Just remember you have options. The other option that you have is you can always look at earlier extra credit to cover these points too. All right, folks, this video ends here.